Hey guys, we're back with a multiplication review for our second math lesson of learning at home. And today we're going to look at different models for multiplication. And yesterday we looked at the area model for multi-digit numbers. And today I want to move you from an area model to an expanded form model where you can see the place values, but we're only using numbers, to a numeric model, abstract, which is just numbers, the form's not expanded. So first, let's start with that area model, and then we'll build an expanded form model off of it. I was kind of thinking about money right now with a lot of people's jobs in different situations, and I was looking for a lot of professional jobs. An average salary is about $23 an hour. So starting teacher, nurse, $23 an hour. And I was looking at an average work week with some overtime where you're working a little more than you're paid for. It's about $54 or 54 hours per week. So 54 hours per week. And let's say we wanted to find our salary for that week. So first, let's take those two factors and decompose them in our area model. And the thing I want you to notice about the area model is your partial products are very clear. It's very clear that you are going to get 4 partial products. When we decomposed these factors and we multiply each factor times the other, we will get 4 partial products, and you know you will get the right number because you will have to fit in every part of your area model. That gets a little more challenging when you get rid of the area model and move to something more abstract where you don't have this visual. And so we're going to start by doing that in expanded form. And I want to link this to this expanded form model right here. We are going to do 50 plus 4 as our first decomposed factor. And we're going to multiply that times 20 plus 3 as our second decomposed factor. Now, I should get 4 partial products underneath here, right? And we are going to link up each partial product in our area model to the partial product in our expanded form model. Let's do that now. I'd like to begin with the 3 times 4 and the 3 times 50. That would correspond to these two partial products in our area model. 3 times 4, 3 times 50. Okay? Let's do those now. First, 3 times 4 is 12. Careful with place value. Here it is here. 3 times 4 is 12. Next, 3 times 50. 3 times 5 is 15. 10 times bigger, 150. Making sure we line up place value. We have the same thing here. Here's 3 times 50, 150. We know we have 2 partial products and 2 to go. Now that we've done 3 times both of our other factors, we're going to do 20 times both factors. And you can see that here. 20 times 50, 20 times 4. All right, 2 times 4 is 8. 10 times bigger is 80. You can see that here. 2 times 4 is 8. 10 times bigger is 80. Last partial product. 2 times 5 is 10. 10 times bigger, 10 times bigger. Put in those 2 place values, 10 times bigger, 10 times bigger, 2 times 5 is 10. Being very careful to line up that place value. Same thing right here. This makes it very clear and very certain that you'll have the right number of partial products. Here you have to be very careful with organization. As you work through that problem, you really have to organize your thinking and understand what you're doing. Otherwise, you'll either get incorrect partial products or place values that are misaligned. So let's look at it again. 3 times 4 is 12. 3 times 50 is 150. 20 times 4 is 80. 20 times 50 is 1,000. Let's take our partial products and get our sum. $1,242 per week for most of those professions when you first start, although you lose some of that to taxes. So here we moved from an area model to a partial products algorithm, but we did it in expanded form. For this next problem, I would like to get rid of the area model and just do the expanded form partial product model. Let's do that problem now. Here's the problem I'd like to do. I was reading an article online about food cart costs to upkeep your food cart, and they were saying if you kept your food cart open 365 days a year, and you're getting fresh ingredients that you get delivered or you pick up every day, you're looking at about $12 on average for each ingredient. So like you're spending $12 in kale or $12 in corn 365 times. Now, you're not actually going to be open 365 days, so this is a rough estimate. It's probably going to be a little lower, but you'd probably want to overestimate your costs. Now, first, let's set that up as a partial products algorithm with expanded form. 300 plus 60 plus 5. And let's decompose that 12 into 10 plus 2. Now, here's where you want to notice patterns and think logically. Notice this pattern in this simpler problem. Each decomposed factor gets multiplied by the other parts. 3 times 4, 3 times 50. 20 times 4, 20 times 50. So noticing that pattern and thinking logically to extend it here, take each factor that is decomposed and you're going to need to multiply it times all the others. But this time we're going to have 3 instead of 2 decomposed factors. 1, 2, 3. So we'll have 2 times 5, 2 times 60, 2 times 300. 10 times 5, 10 times 60, 10 times 300. Okay? That's going to ensure that you have all the partial products that you need. If I was to quickly draw it out, here we had 10 and 2. Here we have 300, 60, and 5. In that area model, again, it's clear. You will have 6 partial products. Here you really have to think logically and be careful. Let's go ahead and begin. 5 times 2 is 10. Done. 2 times 6 is 12 with the place value is 120. 2 times 3 is 6 with 2 place values. Okay, we have done this factor. Let's move on to the 10. And the 10 will need to be multiplied times all 3 parts of our expanded form for our factor again. 10 times 5 is 50. Here's where we have to start being careful of place value. 1 times 6 is 6 with 2 place values. Last one. 1 times 3 is 3 with 1, 2, 3 place values. 6 partial products. We got it. Add those partial products and get your final product. That's about $4,380 per year per ingredient. Of course, prices will be very different for different ingredients. But for planning purposes, that's a lot of money you have to make up in sales. Let's look at our last example problem. And for this one, I was thinking of a news article I saw a long time ago that's resurfaced with the current situation we have with COVID-19, and that is face touching. And for this, what I saw was a range of about 15 to 30 face touches per hour. When I searched for an average, a mean for most people, I came up with 23. So let's look at 23 face touches per hour. Now we have to look at the number of hours in a day, and then consider that we're sleeping for some of those. I'm going to take 8 hours of sleep. Okay. So we have 23 face touches per day times 24 hours minus 8 hours of sleeping. So that's going to leave us with 16 hours. So we've got 23 times 16. Now, I'm not going to use an area model. I am not going to use this expanded form. You'll have to visualize that in your head. We're going to go ahead and do the full partial products algorithm. All right. 23 times 16. 3 times 6. And then we'll have to also do 2 times 6. Remember, notice those patterns and think logically. Here we had 3 times 4, 3 times 50. 20 times 4, 20 times 50. Here we had 2 times 5, 2 times 60, 2 times 300. 10 times 5, 10 times 60, 10 times 300. Noticing those patterns and extending them, we are going to have 6 times 3 and 6 times 20. So 6 times 3 is 18. 6 times 20, 6 times 2 is 12, with the place value is 120. Line up your place values. Next part of our factor is this 1, which is a 10. So notice that there's a place value here. 1 times 3 is 3, with a place value is 30. Last, partial product. Notice there's going to be place values here. 1 times 2, which is really 10 times 20. 1 times 2 is 2, with 2 place values. Gives us 200. So we have 4 partial products because we have 6 times 3, 6 times 2. 2 partial products. 1 times 3, 1 times 2, 2 more partial products, and then we corrected the place value. So 4 partial products altogether. 1, 2, 3, 4. 1, 2, 3, 4. Let's add those up and get our product. 8. 3 plus 3 is 6. And 3. So we have about 368 face touches per day on average. That's a lot. To make sure it's really clear next to this, I want to show it in expanded form. 6 times 3 is 18. 6 times 20. 6 times 2 is 12 with a place value. 10 times 3 is 30. 10 times 20, we've got 1 times 2 is 2 with 2 place values. And hopefully it makes it really clear where those place values come from. Okay? 8, 6, 3. 368 face touches per hour. So in your work today in Google Classroom, you have 3 options. Option 1, if you still feel most comfortable with that area model, that's fine. Because the point of this is understanding what you're doing. So if you become a computer programmer, if you have to check your work when you're using a spreadsheet, things that people have to do in most jobs these days, you understand how the strategies work and what's actually going on with the mathematics. But in real life, you'll use a computer to do these calculations. So I'm not concerned with speed here. I just want you to choose a model that you understand so you understand the idea. And your options are area model, expanded form, or partial products algorithm without expanded form. You do the one that works for you. Bye.